we will discuss about electric fields due to continuous charge distribution. So first of all, we will be discussing about what is continuous charge distribution. So the charges, till now we have considered only the discussion about the point charges. Now we will consider how the charges can be distributed in a surface, in a line, and if you consider something like a solid or uh, solid body, then how the charge will be distributed. Now let us consider a line. Let's say this like a line segment, like this is a line segment. Let us consider this is a line. Then the charges are distributed on this line. You can just consider it as an iron rod. So you can see this is a line. So in this case, the total charge distributed on this is represented as Q, and let us assume that the length of this line is given as L. Then Q over L will give you how much charge is distributed per unit length, and this is given as rho L. Don't confuse it with the rho that we have already discussed. So this is having a unit, this charge is having the unit coulomb, and the length is having the unit in meter. So rho L is the line charge density. So this is known as the line charge density. So this is known as the line charge distribution. So this is the line charge distribution. Line charge. So the line charge distribution is usually it is the charge which is distributed over a line, and the charge density for the line charge distribution is given as charge per unit length. How much charge is distributed per unit length. Now we can consider the electric field due to this line charge. Let us consider a small differential length in the line which is given as dl. So dl is the differential length. Then the charge which is distributed over this dl. So this is your dl. So how much will be the charge? You know the line charge density, that means the charge per unit length is rho L. If you multiply this with dl, you will get how much charge is distributed, which is known as dq, or the differential charge which is distributed over this differential length dl. Then you know that the electric field at some point, let us consider this is the line segment AB, and you have some differential length dl. So in this differential length, the charge distributed is dl multiplied with the line charge density. Now at some point E, the electric field due to this, at some point, let's say some point P, the electric field due to this rho L into dl, that means the differential element is given as, you know the equation for the electric field, that means that differential electric field, okay, this we will be considering as a small electric field due to this small line differential length, small differential length which is having charge. Okay, so this is given as 1 by 4 pi epsilon 0 into the differential charge. Differential charge is given as rho L into dl. So this is the charge divided by the distance. Suppose the distance is r, then divided by r square, and the vector which is pointing in this direction is given as ar. So into ar. And if you want to find the total electric field due to this, it is given as 1 by 4 pi epsilon 0 into rho L into dl divided by r square into ar, and you have to integrate it over the whole length, that it is from A to B. Okay, so this is what, or we can say instead of writing it as A to B, we can write it as over the length, we have to integrate. So this is the electric field due to the line charge. So we will discuss about this more in the next video. Next we will see the surface charge. So this was the first case. Let's say this is A. The next is the surface charge. So let us consider some surface and which is having some charge, and the surface is having some area. Let's say the area is given as S. So the surface area is S, and the total charge on the surface, is total charge on the surface is given as Q. Then we can define the surface charge density as rho S. Previously we have used rho L, now it is rho S as the Q over the total surface area, and this is having the unit coulomb per meter square. So if you consider a small differential surface, let us consider a small differential surface here. Let's say this is ds. If you consider a differential surface ds, then the charge in this on the surface ds, the total charge on this differential surface ds, total charge here is given as rho s into ds. This is the differential charge in this area ds. Now if you have something like some plate like this with the surface area S, now due to this differential surface there will be some electric field at point P. So this differential electric field in this direction is given as, you know, the differential electric field is given as 1 by 4 by epsilon 0 into total charge at this area. So if you consider this small area, the charge is rho s into ds divided by, suppose the length or the distance from this point is r, then it is divided by r square multiplied with this direction. What is this direction? This direction is AR, that means it is the direction of R. So this will be your differential electric field due to this surface charge. Now if you want to find the total electric field at this point, that means the total electric field at this point, then you have to integrate this. That means electric field is given as integral over the whole surface, then 1 by 4 by epsilon 0 rho s into ds divided by r square into AR. So this is the electric field due to the surface charge. So this is the surface charge. Okay. So next we will talk about the volume charge density. So previously we have talked about the surface charge density. Now this is the volume charge density, and it is usually denoted as rho v. So let us consider some volume. Let's say something like some surface like this. It's a object with some volume, so I cannot draw it anyway. It has a three-dimensional view is difficult anyway. So it contains charges. Now if we consider a small volume, differential volume in this, that is having a volume dV, then this dV will be having some charge. Suppose the total charge in this volume total charge. Suppose all these charges are uniformly distributed in this volume, then the total charge will be equal to Q, and the volume is, let's say the volume is V, then the charge by volume is given as rho V, which is given as charge by volume is nothing but the amount of charge, that means the total charge in unit volume. That means rho V is the charge in unit volume. So this is the total charge and this is the volume. So charge per unit volume, and it is having the unit actually coulombs per meter cube. Coulombs per meter cube. So this is the charge per unit volume. So rho V is actually the volume charge density. Volume charge density. It is the total charge which is in a unit volume, which is contained in a unit volume. It is the volume charge density. So if you take this something like a surface, sorry, not a, if you consider a volume like this, and if you consider a differential volume, let's say dV, then it will create some electric field at the point P in this direction. And let's say the distance between this point P and this differential volume is R, and the vector which is pointing, that means and the volume is R, and the direction of this is given as AR. Okay, now we can calculate the differential electric field is 1 by 4 pi epsilon 0 into the charge at this differential volume. What is the charge at differential volume? You know the volume charge density. If you multiply it with the volume, you will get what is the total charge. So this is the charge, or we can say it is dQ. Okay, then divided by the distance between the point and the differential volume is R square, and the direction is AR. So if you want to find the total electric field due to, this is the dE, if you want to find the total electric field due to this, if you want to find the total electric field due to this, that means you have to integrate this dE. That means it is integral over the whole volume 1 by 4 by epsilon 0 into rho V into dV by R square into AR. Okay, so this will be the total electric field due to the differential volume. So due to the total volume. Now this is the electric field due to the surface charge, and this is the electric field due to the volume charge. I hope it is clear to you. Thank you.